Afternoon all. My name is Jasmine Girenshia and I am Operation Executive at Uptown Vacations. I am excited to be here today to share insights and discuss strategies that can help optimize operations and drive efficiency through intelligent API distribution. Today's modern digital ecosystem is powered largely by APIs, and managing them intelligently has become crucial for business agility, reliability, and cost efficiency. Our agenda will guide you through the realities, challenges, and solutions needed to build a highly efficient and scalable API environment. Agenda overview. The reality behind modern API operations. Understanding today's API traffic challenges, microservices, complexity, and operational bottlenecks that IT and development operational teams encounter. The cost of intelligent API distribution. I looked at infrastructure, operational cost implications, and the business value of intelligent distribution strategies. What intelligent API distribution really means. Clarifying the concept from both the technical and business perspective, automation, intelligent routing, availability, and performance optimization. Architecture deep dive. For architects and development operation teams, the underlying architecture that supports intelligent API ecosystems, including gateways, edge layers, and distributed components. Key capabilities: routing, caching, scalability, edge computing, observability. Why these capabilities matter for uptime, latency, customer experience, and cost savings. Walkthrough Recur's journey in intelligent distribution. A real world flow of how requests are handled, optimized, and delivered across intelligent systems. Operational benefits and business value. For business leaders, how intelligent API distribution drives efficiency, reduces operational risk, and accelerates innovation. Implementation strategy and roadmap. Practical steps for teams to adapt or migrate towards intelligent API distribution. Tools and platforms. Overview of popular industry solutions used by leading IT and development operational teams. Common mistakes to avoid. Avoiding pitfalls that often lead to downtime, poor performance, or unnecessary cost. The digital world runs on APIs. APIs have become the foundation of modern digital business. They function as the invisible connectors that enable applications, devices, and systems to communicate seamlessly. Whether a user logs into an app, checks product availability, processes a payment, updates an order, or streams content, APIs are silently powering every step. In essence, APIs are no longer support components, they are the backbone of digital experiences. With the widespread adoption of microservices, cloud computing, mobile apps, and external partner integrations, API usage has grown exponentially. A simple action like viewing an app dashboard can now trigger dozens of API calls across various backend services, cloud regions, and external platforms. As organizations expand across multiple clouds and global markets, APIs have become essential for interconnecting distributed environments. This central role means API performance directly impacts business outcomes. When APIs are slow, applications feel slow. When APIs fail, services break. For sectors like finance, e-commerce, logistics, and healthcare, even minor API delays can disrupt transactions, reduce conversions, and damage customer trust. Reliable APIs are now a competitive advantage. Yet, many organizations still manage APIs using centralized gateways, single region deployments, or outdated routing methods. As traffic scales, these approaches become bottlenecks, leading to latency issues, service interruptions, and rising infrastructure costs. This is why intelligent API distribution is critical today. It optimizes how API requests flow across global regions, intelligently routes traffic based on performance and cost, enhances reliability with failover capabilities, and improves user
Hello?
experience. Sir? In a world where every digital interconnection depends on APIs, intelligent distribution ensures businesses can operate efficiently, scale globally, and innovate faster. How API traffic has exploded. The digital landscape has changed dramatically in recent years, and with it, API traffic has grown exponentially. Modern applications are no longer monolithic. They rely on microservices, cloud platforms, and third-party integrations, each communicating through APIs. This has transformed APIs from simple connectors into high-volume, mission-critical components of business operations. Several factors are driving this surge. First, microservices architecture allows businesses to build modular applications where each component interacts via APIs. Even a simple user action, such as adding an item to a cart, can trigger dozens of backend API calls. Second, mobile devices, wearables, and connected home devices have created millions of endpoints that constantly send and receive data. Each of these endpoints generates API requests, multiplying traffic exponentially. This cloud adoption and multi-cloud strategies mean the data and services are distributed across regions and platforms, further increasing API dependencies. Finally, the rise of third-party integrations for payments, analytics, logistics, and identify services has amplified the number of API integrations a single application handles. The scale of API traffic now impacts both technical performance and business outcomes. Latency, downtime, or failure in API responses can disrupt user experience, reduce revenue, and damage customer trust. For example, a global e-commerce platform during a flash sale may process millions of API requests per minute. Without proper architecture, a single bottleneck could cause widespread service delays. This rapid growth has made intelligent API distribution essential. By routing traffic dynamically, catching responses at the edge, and balancing loads across regions, businesses can maintain performance even under massive demand. Understanding the explosion of API traffic sets the stage of implementing strategies that ensure speed, reliability, and scalability in today's global digital ecosystem. The problem: traditional API distribution fails. As businesses grow and digital ecosystems become more complex, traditional API distribution approaches are struggling to keep pace. Historically, organizations relied on centralized API gateways and static routing mechanisms. While these methods were sufficient for early, smaller scale applications, today's global, multi-cloud, and microservices based systems demand for more intelligent, adaptive approaches. One key limitation of traditional API distribution is centralization. A single gateway or data center handles all traffic, creating a bottleneck. During peak loads like flash sales, financial transactions, or high demand app usage, this centralized model can quickly become overwhelmed, resulting in latency, dropped requests, or even outages. Centralized systems also often lack geographic awareness, meaning users located far from the data center experiences slower responses. Another challenge is rigid routing. Traditional approaches rely on static rules rather than dynamically routing traffic based on factors like server load, latency, cost, or health of the service. This rigidity prevents the system from adapting to sudden spikes in demand or failures in one part of the infrastructure, reducing resilience and reliability. Traditional API distribution also struggles with scaling and caching. Single point caching is limited to one region, which cannot efficiently serve global users. As API calls increase, infrastructure costs rise while performance decreases. Finally, monitoring the observability in traditional setup are often fragmented, making it hard to detect bottlenecks or optimize traffic flows in real time. The consequence: businesses experience slower applications, reduced uptime, higher cost, and frustrated users. In today's fast-paced digital economy, this can directly translate to lost revenue and decreased customer trust. These limitations highlight the critical need for intelligent API distribution, which dynamically optimizes traffic routing, scales across regions, leverages edge caching, and provides real-time observability, ensuring performance, reliability, and global reach. Operational cost of intelligent API distribution. Inefficient API distribution is more than a technical problem. It directly impacts business performance and operational cost. When APIs are poorly distributed or rely on outdated, centralized architectures, organizations face multiple hidden and visible expenses, from infrastructure to lost revenue. First, increased latency impacts user experience. Even millisecond of delay can frustrate customers, reduce conversions, and lower engagement. For customer-facing platforms, slow APIs translate into abandoned carts, dropped sessions, and decreased satisfaction. Internal teams also feel the effects when APIs powering enterprise applications respond slowly, slowing workflows and productivity. Second, inefficient API traffic increases cloud cost. Overloaded gateways, redundant requests, and improper caching force systems to scale more aggressively than necessary. Businesses end up paying for additional compute, storage, and bandwidth, often without measurable improvements in performance. Third, failure rates rise. Centralized or poorly routed APIs are prone to downtime during peak traffic or partial outages, resulting in failed transactions, missed opportunities, and potential SLA violations. Every failure impacts not only operations but also brand reputation. Fourth, slow deployments and updates become consequence. Teams hesitate to deploy changes rapidly because inefficient API networks make testing and rollout riskier. This slows innovation and increases time to market. Finally, multi-region scaling becomes complex and expensive. Poor API distribution often limits deployments to a single region, making global expansion difficult. Organizations struggle to meet latency and availability expectations across geographies. In short, inefficient API distribution results in slower applications, higher cost, reduced reliability, and limited scalability. From a business perspective, when APIs slow down, revenue drops, infrastructure costs rise, and customer trust erodes. Intelligent API distribution mitigates these risks by optimizing routing, caching, scaling, and monitoring, improving both technical performance and business outcomes. Enter intelligent API distribution. Traditional API distribution methods struggle to meet the demands of modern, globally distributed applications. Enter intelligent API distribution, a smart, automated, real-time strategy designed to optimize the delivery, performance, and reliability of APIs across distributed environments. Unlike simple load balancing or centralized gateways, IAD leverages context-aware decision-making to route API requests dynamically. Requests are directed to the best endpoint, based on real-time factors such as latency, server load, geographic proximity, and service health. This ensures that users receive fast and reliable responses no matter where they are in the world. Caching plays a central role in intelligent distribution. Frequently accessed API responses can be stored at the edge or in regional caches, reducing unnecessary backend calls and minimizing latency. Intelligent replication ensures that APIs and their supporting data are available across multiple regions, increasing resilience and fault tolerance. IAD also automates scaling and failover, adjusting resources proactively during traffic spikes and rerouting requests if a service experiences issues. Combined with continuous monitoring and observability, it provides actionable insights to optimize performance, reduce infrastructure costs, and prevent downtime. The business benefits are clear: faster response times, improved reliability, lower operational cost, and the ability to scale application globally without adding complexity. For technical teams, IAD simplifies management, enables smoother deployments, and reduces operational risk. Put simply, intelligent API distribution is not a single gateway or basic load balancer. It's a global, context-aware API delivery system that ensures performance, reliability, and scalability by supporting modern business and user demands. Intelligent API distribution equal to performance plus efficiency plus resilience. Intelligent API distribution is more than a technical upgrade. It is a strategic enabler for modern digital businesses. Its value lies in delivering three core benefits: speed, stability, and scalability, which together ensure performance, efficiency, and resilience. Number one, speed, minimizing latency. Users expect instant responses, but whether they are booking a flight, making a payment, or accessing enterprise dashboards. IAD minimizes latency by routing requests to the nearest or best performing API endpoints using real-time data and server load, network conditions, and geographic location. Edge and regional caching further reduce response times by serving frequently access data closer to the user. The result: faster applications, improved user experience, and higher conversion rates. Number two, stability, preventing outages. Unplanned downtime can be costly and damage to brand reputation. IAD increases stability through intelligent failover, automated retries, and multi-region replication. If an API endpoint fails, traffic is seamlessly rerouted to healthy endpoints without user disruption. Circuit breakers and real-time monitoring allows proactive management of potential failures, reducing downtime and ensuring service reliability. Number three, scalability, handling global traffic. As businesses expand, their applications must handle growing and unpredictable traffic across multiple regions. IAD enables automated scaling, dynamically allocating resources based on traffic patterns and distributing loads globally. This ensures consistent performance even during peak periods, product launches, or promotional events, without requiring manual intervention or excessive infrastructure cost. By combining these three pillars, intelligent API distribution transforms API delivery into a robust, efficient, and high-performing system. It empowers organizations to meet user expectations, optimize operations, and scale globally, turning API infrastructure into a strategic business asset rather than a bottleneck. Architecture overview. Intelligent API distribution relies on a carefully designed architecture to deliver performance, reliability, and scalability. At the top level, user requests enter the system and are first handled by the global load balancer, which dynamically routes traffic based on factors like latency, server health, and geographic location. Requests then pass through the edge network, which provides caching and content delivery closer to users, reducing response times and minimizing backend load. From there, traffic reaches regional gateways, which distribute requests to the appropriate microservices responsible for processing business logic. This multi-layered approaching ensures that APIs are resilient, responsive, and efficiently scaled across regions. Finally, an observability layer continuously monitors performance, latency, errors, and usage patterns, providing actionable insights for optimization. This end-to-end architecture enables organizations to deliver fast, reliable, and global scalable API-driven experiences while maintaining visibility and control over system health. Key capability. Number 1, intelligent routing. Intelligent routing is a cornerstone of modern API distribution. Unlike traditional routing, which relies on static rules or a single gateway, intelligent routing acts as a dynamic decision engine, evaluating real-time factors to deliver each API request along the optimal path. This capability ensures APIs are fast, reliable, and cost-efficient across distributed environments. There are 5 main types of intelligent routing. Latency-based routing directs requests to the endpoint with the lowest response time, minimizing user perceived delays and improving application responsiveness. Geo-aware routing routes traffic to the nearest regional service server or data center, enhancing performance for users worldwide. Load-aware routing balances traffic across servers based on current load, preventing bottlenecks and reducing failures. Cost-optimized routing chooses endpoints that minimize operational cost, such as cloud usage or data transfer fees, without compromising performance. Health-aware routing detects failing endpoints and automatically reroutes traffic to healthy services, ensuring continuous availability. By combining these strategies, intelligent routing transforms API traffic management into a smart, self-optimized system rather than blindly following static paths. It makes decisions in real time, improving speed, reliability, scalability, and cost efficiency. Critical, more modern, globally distributed applications. Capability. Number 2, multi-layer caching. Multi-layer caching is a critical capability in intelligent API distribution that significantly improves performance, reduces latency, and lowers operational cost. By storing frequently accessed data closer to the user or the consuming service, caching minimizes repeated backend processing and reduces API traffic, often by 60 to 90%. There are multiple layers of caching. Edge caching. Data is stored at the edge of the network near end users, reducing the distance, request travel, and improving response times. Regional caching. Frequently accessed data is replicated in regional nodes or data centers. Optimize performance for users across different geographies. API response caching. Entire API responses are cached, allowing repeated requests for the same resource to be served instantly without hitting the backend. Object caching. Specific data objects or components such as database queries or computed results are cached for quick retrieval. CDN integration. Content delivery networks extend caching capabilities for static content and API responses, improving performance globally. By combining these layers, organizations can handle higher traffic volumes without proportionally increased backend resources. Multi-layer caching also improves reliability. If a backend service experiences issues, cached data can still serve user requests. For businesses, this means faster APIs, lower cloud cost, improved user satisfaction, and more efficient scaling. In short, multi-layer caching is a foundational tool for intelligent API distribution, enabling faster, more reliable, and cost-efficient digital experiences. Number 3, Load Aware Gateway Mesh. Load Aware Gateway Mesh is a critical component of intelligent API distribution that ensures optimal performance, reliability, and resource efficiency in distributed systems. Unlike traditional static load balancing, which evenly distributes traffic across servers without considering real-time conditions, a load-aware gateway mesh dynamically adjusts routing based on current server load, latency, capacity, and predicted traffic patterns. Key capabilities include predictive scaling. The system anticipates traffic spikes like product launches or seasonal peaks and scales resources proactively to prevent bottlenecks and maintain performance. Dynamic load balancing. Traffic is continuously redistributed across gateways and microservices according to real-time conditions, ensuring no server is overloaded while others remain idle. Automatic traffic shaping. The mesh intelligently prioritizes requests, throttles non-critical traffic, and allocates resources to maintain service quality for high-priority users. Resource efficiency. By intelligently directing traffic and scaling on demand, the system maximizes utilization of available resources, reducing cloud cost and avoiding unnecessary over-provisioning. The difference from static load balancing is significant. Instead of blindly splitting traffic, the load-aware mesh acts as a self-optimizing network, adapting to changing conditions in real time. This ensures fast, reliable API delivery even during sudden surges or failures, while keeping infrastructure costs in check. For global applications, a load-aware gateway mesh is essential for maintaining performance, reducing latency, and improving operational efficiency. Number 4, multi-region and multi-cloud. Modern applications demand global reach, high availability, and flexibility across multiple cloud providers and geographic regions. Multi-region and multi-cloud deployments is a core capability of intelligent API distribution that enables organizations to achieve these goals while maintaining performance, reliability, and operational efficiency. Deploy anywhere. APIs and services can be deployed across multiple regions and cloud providers, public, private, or hybrid. This allows organizations to meet compliance requirements, optimize for local regulations, and reduce vendor lock-in. Unified traffic management. Despite the complexity of multiple regions and clouds, intelligent API distribution provides a centralized control plane to manage traffic seamlessly. Requests are dynamically routed based on latency, load, cost, and health, ensuring consistent user experience worldwide. Failover resilience. In the event of a region or cloud failure, traffic is automatically rerouted to healthy regions or providers without impacting users. Multi-region redundancy reduces downtime risk, protects SLAs, and maintains business continuity. Faster global reach. By distributing API endpoints geographically and across multi-clouds, organizations can serve users closer to their location, reducing latency and improving application responsiveness. Overall, multi-region and multi-cloud strategies, when combining with intelligent routing, caching, and load-aware distribution, provide scalability, resilience, and operational efficiency for global applications. This capability ensures that businesses can grow internationally, maintain high service levels, and optimize infrastructure costs without compromising performance. Number 5. Observability and insights. In intelligent API distribution, data drives smarter decisions. Observability and insights provide a comprehensive view of how APIs are performing, enabling teams to proactively identify issues, optimize performance, and ensure reliability across distributed systems. Tracing. Detailed request tracing tracks API calls across microservices and regions. It helps identify slow endpoints, bottlenecks, or failures in real time, allowing teams to resolve issues before they impact users. Latency heat maps. Visualizations of latency across regions reveal geographic performance differences. Teams can pinpoint areas with high latency and adjust routing, caching, or scaling strategies to improve user experience globally. Traffic analytics. Monitoring API request patterns, volumes, and usage trends provides insight into peak traffic periods, popular endpoints, and system load. These analytics support predictive scaling, cost optimization, and capacity planning. API dependency graphs. Visualizing dependencies between APIs, microservices, and data resources highlights potential single points of failure and helps engineers understand the impact of changes or outages. By combining these capabilities, observability transforms raw operational data into actionable insights. Teams can make informed decisions about traffic routing, caching, load balancing, and multi-region deployments. It also enhances reliability, reduces downtime, and ensures performance SLAs are met. Simply put, data is the backbone of intelligent API distribution, enabling proactive optimization and informed decision making at every level of the system. Deep dive. Request journey. Understanding the journey of a single API request is foundational to appreciating the value of intelligent API distribution. Each request passes through multiple layers designed to optimize speed, reliability, and efficiency. User request enters global load balancer. The request first hits a global entry point that routes traffic based on latency, load, health, and geolocation. Geo-identification. The system determines the user's location to optimize routing and compliance with regional regulations. Policy evaluation. Security, access, and operational policies are applied, ensuring that requests are authorized and meet organizational standards. Cache lookup. Frequently requested data is retrieved from edge or regional caches to reduce backend load and minimize latency. Regional routing. The request is dynamically directed to the best regional gateway or service cluster, taking into account real-time conditions like server load or failures. Microservice processing. The backend microservices handle the business logic, query databases, or invoke downstream APIs to fulfill the request. Response returned through edge network. Data is sent back via edge nodes to reduce latency and ensure rapid delivery to the user. Metrics captured for continuous improvement. Observability tools record latency, errors, traffic patterns, and dependencies, feeding analytics for optimization and predictive adjustments. This journey illustrates how intelligent routing, caching, load-aware distribution, multi-region deployment, and observability work together. Each layer is essential for ensuring high performance, resilience, and global scalability, making this journey the backbone of a reliable API ecosystem. System resilience mechanisms. In modern API-driven architectures, resilience is critical to ensure uninterrupted service despite failures, traffic spikes, or infrastructure issues. Intelligent API distribution incorporates multiple mechanisms to maintain performance and availability even under stress. Circuit breakers. These prevent repeated recurs to failing services, protecting the system from cascading failures. When a service shows repeated errors, this circuit trips, temporarily halting request until the service recovers. Retries. For transient failures, automatic retries attempt to process the request again, often with exponential backoff to avoid overwhelming the system. This improves reliability without manual intervention. Timeouts. Requests that take too long or terminated gracefully, preventing slow responses from blocking other traffic and reducing overall latency. Active-passive failover. Secondary systems remain on standby and automatically take over if the primary system fails, ensuring continuity of service. Multi-zone redundancy. Distributing services across multiple availability zones or regions mitigates the risk of localized outages. Traffic can be rerouted to healthy zones, maintaining uptime and performance globally. Together, these mechanisms ensure that APIs remain responsive, scalable, and reliable under varying conditions. They are especially critical for global applications where failures in a single region can impact millions of users. Implementing these resilience strategies reduce downtime, protect SLAs, and enhances user trust, making them an integral part of intelligent API distribution. Security in distribution API system. In distributed API architectures, security is not optional, it's foundational. Intelligent API distribution ensures robust protection by embedding security mechanisms at multiple layers from the edge to backend services. Token verification at edge. Each request is authenticated at the network edge before entering the system. This prevents unauthorized access early, reducing the risk of malicious traffic reaching critical infrastructure. Zero trust transport. Mutual TLS ensures that both client and server authenticate each other, encrypting all traffic to protect data in transient and prevent man-in-the-middle attacks. This aligns with the zero trust principle where no communication is inherently trusted. API firewalls. These enforce policies, block malicious patterns, and prevent attacks such as SQL injection, cross-site scripting, or request floods. Firewalls act as the first line of defense for API endpoints. Bot protection. Automated traffic from bot can strain systems, compromise data, or manipulate analytics. Bot detection and mitigation tools identify and block malicious automation without affecting legitimate users. Global threat detection. Continuous monitoring across all regions identifies unusual traffic patterns, DDoS attacks, or emerging threats. Integrating threat intelligence enables proactive mitigation before attacks impact users or infrastructure. By combining these strategies, distributed API systems maintain confidentiality, integrity, and availability. Even in complex multi-region deployments, security becomes an integral part of API distribution, ensuring both performance and trust while safeguarding users and organizational assets. Industry use case e-commerce. E-commerce platforms face high expectations for speed and reliability, especially during peak sales or promotions. One common challenge is slow checkout experiences for users located outside the primary region, which can lead to abandoned carts, reduced revenue, and frustrated customers. Problem: traditional API distribution routes all checkout traffic through a centralized gateway in the primary region. Users further away experience higher latency, slower page loads, and delays transaction processing. Additionally, backend servers must handle all traffic, leading to increased infrastructure cost. Solution: implementing intelligent API distribution with global routing and edge caching addresses these challenges. Requests are routed to the nearest regional endpoint or edge node, reducing round-trip time. Frequently accessed checkout data, such as provide catalogs, pricing, and inventory, is cached at the edge. This reduces backend calls, minimizes latency, and distributes load more evenly across infrastructure. Outcome: checkout processes become 2x faster, significantly improves user experience and conversion rates. Backend load decreases, enabling 30% infrastructure savings by reducing unnecessary server utilization. The platform gains resilience, automatically rerouting traffic if a regional server or gateway fails. Teams can scale globally without major operational overhead, supporting sales, spikes, and international growth. This use case highlights how intelligent API distribution transforms user experience and operational efficiency, turning latency and traffic challenges into measurable business benefits. Demonstration walkthrough. A demonstration walkthrough helps participants visualize the power of intelligent API distribution, even conceptually. This section is designed to create a wow effect by showing how the system adapts in real time to optimize performance, reliability, and cost. Global latency comparison. Imagine users in multiple regions accessing the same API. The system dynamically routes requests to the nearest or best performing endpoint, demonstrating how latency is minimized for everyone, regardless of location. A heat map can visually show response times improving across regions. Catchy hit versus miss. Requests for frequency access data are served instantly from edge or regional caches, creating catchy hits, while less common requests trigger a backend call or catchy miss. Highlighting this difference illustrates how caching reduces load and speeds up responses. Traffic shifting during spike. During sudden surges, such as a product launch, traffic is redistributed automatically across gateways, microservices, and regions. This prevents overload, maintains performance, and showcases the system's predictive scaling and load-aware capabilities. Failover event handling. In a simulated failure of a region or endpoint, requests are rerouted seamlessly to healthy nodes. This demonstrates multi-region redundancy and resilience, ensuring uninterrupted services. This conceptual walkthrough makes abstract capabilities tangible, showing how intelligent API distributed continuously optimizes routing, caching, and scaling. By visualizing latency improvements, cache efficiency, traffic management, and failover handling, participants can see the real business value summary. Intelligent API distribution is not just a technical improvement, it delivers tangible business value across multiple dimensions, helping organizations achieve faster, more efficient, and more resilient digital operations. Faster digital experiences. By optimizing API routing, caching, and load distribution, users experience lower latency and quicker response. Faster digital experiences increase engagement, reduce abandon rates, and enhance overall satisfaction, directly impacting revenue and brand perspective. Lower operational cost, multi-layer caching, load-aware routing, and multi-region deployments reduce unnecessary backend load, minimize cloud consumption, and prevent over-provisioning. Organizations achieve significant cost savings while maintaining high performance. Reduced risk. System, system resilience mechanisms, failover strategies, and security layers protect against outages, data breaches, and unexpected traffic spikes, reduce downtime and enhance security, help maintain SLAs, and protect brand reputation. Faster innovation cycles. With intelligent API distribution handling performance, scaling, and resilience, development teams can focus on delivering new features and innovations without worrying about infrastructure bottlenecks. This accelerates time to market. Better customer retention. Reliable, fast, and secure digital services improves user satisfaction and loyalty. Happy customers are more likely to return, make repeat purchases, and advocate for the brand, creating long-term business value. Technical advantages. Intelligent API distribution provides significant technical advantages that enhance the stability, scalability, and efficiency of modern applications. These benefits are particularly valuable in complex, globally distributed systems and microservice architectures. Resilient microservice communication. APIs often connect multiple microservices that must communicate reliably. Intelligent routing, failover mechanisms, and observability ensure that services remain reachable even under high load or partial failures. Circuit breakers, retries, and multi-zone redundancy further protect communication pathways, reducing the risk of cascading failures. Easier multi-region deployment. Deploying applications across multiple regions is simplified through unified traffic management and intelligent routing. APIs automatically direct requests to the nearest or healthiest regional endpoints, reducing latency and ensuring consistent users' experiences worldwide. Teams can scale globally without the operational overhead of manually configuring multiple deployments. Lower load on backends. Multi-layer caching, predictive load balancing, and traffic shaping reduces the number of requests hitting backend services. This improves response times, reduces server stress, and lowers cloud cost while maintaining high availability and reliability. Scalable architecture foundations. Intelligent API distribution creates a flexible modular architecture that can handle variable and growing traffic. Services can scale horizontally across regions, clouds, or clusters without requiring extensive reconfiguration. This foundation supports future growth, new features, and rapid innovation cycles. Implementation roadmap. Implementing intelligent API distribution requires a structured, phased approach to ensure performance, reliability, and scalability. A clear roadmap helps organizations move from assessment to continuous optimization efficiently. Phase 1 Assessment. Evaluate current API architecture, traffic patterns, latency bottlenecks, security requirements, and infrastructure cost. This baseline informs design decisions and prioritization. Phase 2 Distributed gateway setup. Deploy global and regional gateways to help handle API traffic. This enables the foundation for routing, scaling, and resilience. Phase 3 Edge plus regional caching. Implement caching at edge nodes and regional gateways to reduce latency and backend load. Prioritize high traffic endpoints for immediate impact. Phase 4 Intelligent routing configuration. Set up latency-based, geo-aware, load-aware, cost optimize, and health-aware routing rules. Test routing behavior under different scenarios to ensure performance. Phase 5 Observability Integration. Integrate monitoring, tracing, traffic analytics, and dependency mapping to gain visibility into API performance and system health. Phase 6 Multi-region Scaling. Expand deployments to multiple regions and, if needed, multiple clouds. Enables failover, redundancy, and automated traffic shifting for resilience and low latency. Phase 7 Continuous Optimization. Use collected metrics and insights to fine-tune routing, caching, load balancing, and security policies. Establish a cycle of continuous improvement for sustained efficiency and performance. Readiness Checklist. Before implementing intelligent API distribution, organizations should evaluate their current infrastructure and operational challenges. A readiness checklist helps teams to improve pain points, determine where their systems would benefit from a distributed intelligent API approach. Is your traffic global? If your users are spread across multiple regions or countries, centralized APIs can create latency and inconsistent experiences. Intelligent API distribution addresses this by routing traffic to nearest or best performing endpoints. Are your APIs centralized? Centralized architectures may overload backend systems and increase latency for distant users. Distributed gateways and multi-region deployments can alleviate this, improving performance and resilience. Are your response times inconsistent? Variability in response times often indicates bottlenecks, uneven load, or network inefficiencies. Multi-layer caching, intelligent routing, and load-aware distribution help stabilize performance. Are cloud costs rising? Inefficient traffic patterns, repeated backend calls, and over-provisioned servers drive up operational expenses. Optimizing routing, caching, and scaling can reduce unnecessary load and lower cost. Are outages frequent? Frequent downtime, partial failures, or cascading issues reveal gaps in resilience. Circuit breakers, multi-zone redundancy, failover mechanisms, and observability provide a robust safety net. Tools and platforms. Implementing intelligent API distribution requires a combination of gateways, service mesh, edge networks, and observability tools. Understanding the right platforms and their roles helps the organizations build scalable, resilient, and performance API ecosystems. Gateways. API gateways are the entry point of traffic, managing routing, security, and policy enforcement. Tools like Kong, Apache, NGINX, and AWS API Gateway provide centralized control, authentication, throttling, and traffic shaping. Gateways form and foundation of intelligent API distribution by directing records efficiently. Service mesh. Service meshes handle service-to-service communication within microservice architectures, providing observability, load balancing, retries, and security. Platforms like Istio, Linkerd, and Consul enables transparent routing, circuit breakers, and policy enforcement at the service level, complementing API gateways. Edge. Edge networks extend caching, routing, and security closer to end users, reducing latency and improving performance. Providers such as Cloudflare, Fastly, and Akamai accelerate content delivery and provide DDoS mitigation, bot protection, and global reach. Observability. Monitoring and analytics are critical for operational insights. Tools like Grafana, Jafer and Datadog provide tracing, metrics, dashboards, and alerting, enabling teams to identify bottlenecks, track traffic patterns, and continuously optimize performance. Quick wins implement in 30 days. For organizations looking to improve API performance quickly, several practice steps can deliver measurable results within 30 days. These quick wins focus on optimizing routing, caching, monitoring, and traffic management without recurring full-scale infrastructure changes. Enable geo-routing. Direct user requests to the nearest regional endpoint or edge node. This reduces latency and improves user experience globally, even with minimal infrastructure changes. Add edge caching. Cache frequently accessed data at edge locations to reduce repeated backend calls. Edge caching improves response times and decreases server load, providing immediate performance benefits. Deploy distributed gateways. Implementing regional or distributed API gateways ensures traffic is balanced across locations, increasing resilience and reducing single points of failure. Introduce traffic throttling. Protect backend services from sudden spikes while limiting request rates per client or endpoint. Throttling prevents outages and maintains system stability during peak loads. Turn on tracing best metrics. Enables observability tools to capture request traces, latency, errors, and traffic patterns. Even basic metrics allows teams to identify bottlenecks and prioritize further optimizations. Common mistakes to avoid. When implementing intelligent API distribution, certain pitfalls can limit effectiveness, increase cost, and hurt user experience. Recognizing these common mistakes helped organizations build more resilient and efficient API systems. Relying on one region. Centralized deployment creates latency for distant users and increases the risk of outages affecting a large user base. Multi-region distribution is essential for global performance and resilience. Overusing central gateways. Sending all traffic through a single gateway can create bottlenecks, increase latency, and limit scalability. Distributed gateways and regional routing reduce stress on any single node. No caching strategy. Failing to implement caching at edge and regional layers leads to unnecessary backend load, slower responses, and higher cloud cost. Strategic caching improves performance and efficiency. Capacity planning. Without understanding traffic patterns or using predictive scaling, systems risk being overwhelmed during spikes or underutilized during low traffic periods. Proper planning ensures reliability and cost efficiency. No visibility into API performance. Lack of tracing, metrics, or monitoring prevents teams from identifying bottlenecks, failures, or security issues. Observability is critical for continuous optimization and maintaining SLA compliance. Key takeaways. As we conclude the webinar, it's important to distill the core lessons about intelligent API distribution and its impact on modern digital operations. Intelligent API distribution equal to fast, scalable, efficient operations. By combining intelligent routing, multi-layer caching, load-aware distribution, and multi-region deployment, organizations can handle global traffic with high performance, resilience, and minimal operational overhead. Essential for global apps and microservice architectures. Distributed applications and microservices require reliable, low latency communication. Intelligent API distribution ensures that the user experience consistent performance regardless of their location, while microservices remain interconnected and resilient. Reduces cost and increases reliability. Multi-layer caching, predictive routing, and traffic shaping reduce unnecessary backend load, lowering cloud cost, resilience mechanisms like failover, circuit breakers, and multi-zone redundancy prevent downtime and protect SLAs. Enhances both user experiences and business growth. Faster, reliable, and secure API improve user satisfaction and retention. Operational efficiency frees teams to innovate, launch features faster, and expand globally, directly contributing to business growth and competitive advantage. If you have any questions, please ask.
Hi, Jasmine.
Hi.
So I have a question. So we use a lot of third-party APIs, right? Will intelligent API distribution help if the third-party APIs goes down or respond slowly?
Absolutely. Intelligent API distribution can implement failover and retrace for external APIs and even catch frequently requested third-party data at the edge. This means that temporary slowdowns or failures in external services won't disrupt your application, ensuring smoother user experience and higher reliability.
Okay. Thank you.
Any other questions? Okay, I hope this session helps you adopt intelligent API distribution to improve performance, scalability, and operational efficiency. Thank you for your time and participation. Thank you, everyone.